delay, I will hand it over to you, Rob, and thanks again for doing this.
Yeah, absolutely. I'm really glad to have this opportunity. And first, I have to apologize for my background. I'm up in Port Angeles, Washington right now. I'm doing a safety audit. So this is my hotel room that you're seeing behind me. And so it's um, uh, slightly earlier here, so we're just about 3 hours behind, but it's good. So without further ado, I'll kind of dive right in. So this is a little bit about me, kind of like what Dominic was saying. I graduated from the Coast Guard Academy in 2007, went right to flight school down at Pensacola, Florida. So we trained with the Navy, Marine Corps, and at first I learned how to fly a fixed wing, the T-34, and then transitioned over to the TH-57 helicopter, and then flew that, and then had a couple of really cool aviation units. I did search and rescue out of North Bend, Oregon, and then counter narcotics flying out of Jacksonville, Florida, which I'll talk about a little later on. It's kind of an interesting case study. My current job is on the Aviation Training and Standardization Division Chief at our Aviation Training Center in Mobile, Alabama. And so what I do there is I develop and distribute all of our aviation training, safety training, to our flight safety officers. And I do all of our CRM work for the Coast Guard, develop that, and then send it out to our aviators. So a pretty interesting job, and really excited about it. And also part of the job, which I'm doing right now, is cultural assessments and aviation safety assessments at all of our air stations throughout the Coast Guard. So right now I'm at Air Station Port Angeles, and I've been here for the last 3 days or so, just talking to people and trying to get a good grasp on the safety culture at the unit. At Hitron, where I did the counter narcotics stuff, that's really where I started getting into safety. And so as a flight safety officer, where I did mishap analysis and kind of understanding how people are reacting, trying to get reporting and doing those more complex investigations. So from there, I did investigations ranging from like overtorques, which is a pretty benign thing that happens to helicopters, especially the one that I fly, to major Class B aircraft damage, where we had towing incidences and banged up some aircraft to the point where it was millions of dollars worth of damage. So a lot of responsibility there. So I have just over 3,000 flight hours in the H-65 Dolphin helicopter. So you can see that behind me in that picture there, and that's our primary short-range recovery helicopter. And we can also outfit it with weapon systems to do our counter-narcotics missions. And about 1,000 of those flight hours are shipboard based, meaning that I took off and recovered to the ship. And with my counter-narcotics experience, I was almost entirely at night, which I'll talk about a little later on when we discuss fatigue. I'm also a Coast Guard instructor pilot, and so at Hitron, I did a lot of training and instructing. And after I went to grad school, I'm slowly kind of getting back into an IP role, even though it's not really my primary job. The Coast Guard's letting me kind of continue flying and doing a little training of our people, which is really great for me. I'm also a CFI, CFII, and have my ATP for helicopters. So gone through that process and I understand it. And as was said earlier, I have a master's in science in human factors and product designs from Tufts University. And that was a Coast Guard sponsored program in order to get me a little more experience in the safety world so I could do what my job is now. And then also I'm a PhD candidate at Tufts University, and I'll discuss a little bit of my work because it's pretty applicable in the fatigue realm. So without further ado, this is a little bit of a video that shows what I did at Hitron, because I'm going to come back and talk about it at the end of the presentation. So hopefully the audio and everything works. And so if it doesn't work, someone just let me know.
Perfection requires excellence from all angles. All components must work together in a precise evolution single moment. That moment that defines us, that is us. Meticulous preparation is key for that one anomaly that will try to throw you off your game. To be flawless is to adapt and overcome all obstacles, fully prepared with precision focus. Our refined system stems from a concept led by those who came before us.
Target site. I'm tracking them on clear. 2 outboard.
Those who resist our orders will encounter an experience that will not be forgotten. Our leaders are built to anticipate for change and execute with precision.
Ready after warning shot.
For such a complex evolution, our mission is simple. Those who run will be stopped.
Ready after safety fire. Misfire. Roger, clicking fire.
They will tremble when they hear the point of impact that defines who we are. We are the hunters in the sky. We are the eye behind the crosshairs. From top to bottom, we are PHDWORK.
So, like you saw at PHDWORK, what we did was it was purely counter-narcotics. So I didn't do search and rescue, anything like that. It's a really complex mission set that a few aviators in the Coast Guard get to experience. And I'll circle back to it a little bit, but I just wanted to give you a little bit of an indication of what we did. So what I say later on makes a little more sense. There we go. So as we kind of, shift our minds to the human factors world, one big thing that's important is to understand, what is human factors? And depending on where you are and your interpretation, it can be a little different. And so for me, human factors is the human element of complex systems, how people are interacting with the machine and how to reduce the likelihood of creating human mistakes, human-based error. Because as machines have gotten more and more complicated, it's been harder for humans to work that interface unless you have, a great UI, UX designer that is incorporating a lot of complex mechanisms in order to help the human out. And then, why is it important? It's because no matter what, people are always going to play a central role in technology. Because even as we're developing tech, a person is, writing the code, putting in, the ones and zeros. So mistakes can still happen there that we've seen in, various aviation mishaps in the recent years. And then at the end of the day, people are always going to make mistakes. And it's how do we understand those mistakes and reduce the likelihood of human-based error in the future. And so human factors has been around for a really, really long time. It's been studied for 100+ years, and kind of the initial human factors experts, I would say, were Frank and Lillian Gilbreth, and they attempted to reduce human error in medicine. And for all the pilots out there who know about the challenge and response system, that came from them. They started that in operating rooms because nurses were giving doctors the wrong instruments and performing kind of wrong procedures because they weren't all on the same page. And so that's why, a doctor would call out scalpel, a nurse would say scalpel, and then hand the doctor a scalpel, kind of a thing. Very similar to how in aviation, as we go through a checklist, I'll say something like landing gear, and then the pilot that's kind of monitoring will look and say, yep, landing gear, 3 wheels are down, kind of a thing. And so I hope that's all kind of a norm for you all. And then also in the aviation world, the people that, really started human factors and looking at the human machine interface were the Wright brothers, which makes sense because, they were kind of the first ones to take off in flight. And so they developed, an angle of attack sensor so they could understand, when the aircraft is going to stall and give them a little bit of a heads up, alert them of a potential problem. They introduced a stick pusher, reducing the pilot workload. to make it a little easier to control the aircraft so it wasn't as, physically demanding and fatiguing. And they also incorporated a rudder boost trim and trim control for greater aircraft authority, so they could have more control touch and manipulate the aircraft with a little more fine tune. And probably one of the biggest things is they incorporated a seatbelt into the aircraft, because I'm sure as they were testing, they were getting banged around pretty good and maybe ejected from the aircraft, and thought it makes sense for them to stay attached to the aircraft somehow. And then prior to World War II, really the social norm, like with the Industrial Revolution, was humans were adapting to machines, and that created a lot of injuries. And in that period, like in the steel mills and in the real dangerous jobs, textile fabrication, things like that, humans and people were getting hurt because there weren't a ton of guards, things like that on the machines to reduce the likelihood of human error and getting hurt. And so these companies started realizing that it's better to invest in some type of safety mechanism, guards or better training, as opposed to having to retrain a human to continue to do a job when someone got hurt. And so that really started putting human factors and engineering psychology into the mainstream into these factories because of safety and efficiency. Post World War II, machine design really had to start taking human limitations into consideration. They realized as the machines were getting more and more complex, displays had to be a little different in order to provide the necessary information at the necessary time. Knobs were different because now aircraft were operating at higher altitudes, and at a higher altitude and potentially an unpressurized aircraft, it's really, really cold. And so pilots are wearing thick gloves. And so they don't have the finger dexterity that they normally would. And then also indications were getting different, like alerts to the pilots and the air crews had to be a little different in different environments. And that top image up there, that the Liberator, that was kind of one of the first human factors, I would say almost disasters, because it was a really complex machine. And it wasn't necessarily laid out really, really well for pilots. And they had a few issues with the aircraft, with controllability, and how pilots understood what they were, what kind of information they were getting. And then as we've progressed, beyond World War II, machines have gotten very, very complex to where now the human is the limiting factor. My case in point is the F-35 Joint Strike Fighter, where it can certainly outperform the human. It can take a much higher G load than what humans can handle. You have to process information, much quicker because it's a really fast and complicated aircraft. And so now humans are the ones that are, really trying to catch up to the machines, and designers have to take that into account, that it's really important to understand the limitations of humans throughout the design process. And I'm not sure if anyone saw just about a month ago, there was a really neat kind of webinar talk that put human F-16 pilots against F-16s that were piloted by artificial intelligence, which was really, really interesting. So it was an F-16 Air Force pilot in a simulator going against an AI F-16. And amazingly, the AI aircraft won the dogfight. I think it was 5 out of 5 times. And so if anyone is interested in that, I can pass the information to you after this is over. But it was really, really interesting to see. And it just kind of shows that, machines are getting smarter, more complex, and, can really start outperforming humans. And so as we shift a little deeper into human factors, this is a really interesting model called the PEAR model. And this is, in my opinion, a nice way to think of human factors, because it really encompasses a lot. And so when you think of human factors, you have to start thinking of, the people who do the job. What are their characteristics, limitations? and capabilities. And then for me as an operator, especially previously when I did search and rescue and the counter narcotic stuff, what's the environment that they're working in? Is it daytime? Is it nighttime? Is it high altitude? Is it, nap of the earth kind of flying? Where are they going to be expected to be operating their systems in? And then what kind of actions are they performing? Is it a helicopter that's going to go, 100 miles offshore in 15 to 20 foot seas to execute a hoist? Is it one of our fixed wing aircraft that is going to be up at altitude, but then having to descend to about 200 feet to drop a life raft to someone in distress? What kind of tasks are they having to perform in their mission sets? And then lastly, what resources are necessary to complete the job? What do they need, for maintenance? What do we expect them, ergonomically and using different tools and machines to complete maintenance jobs? What type of PPE do they need? What type of training is necessary for their to complete their task? And the PEAR model is nice because it kind of mirrors up to the Coast Guard model and the DoD model. And so this is what we use for our mishap analysis, essentially. And so this is a kind of an image that's adapted from Reason, James Reason, with the Swiss cheese model. And so as a Coast Guard safety officer, one of the things I'm looking at is the HVACS 7.0 classification system, which this essentially is. And so here we're looking at organizational influences, like the culture, supervision influences, like, do you have adequate supervision? Is the people knowing about the problem, do they actually understand what it is? Preconditions, that would be kind of like environment, external factors, fatigue. And then you get down to acts, which is really the human. Why are they doing, why did they make the decision based upon everything else? So this is it's a pretty interesting model. If you're interested more in it, you can just Google HVACS 7.0 and it'll bring you right to a DoD public website where you can get a little more information on how we classify mishaps through analysis using the HVACS system. And so I'm just going to dive into just a couple pieces of human factors stuff, which is kind of what I've learned is more of my passion, and things that we are exposed to almost every day, especially as pilots. And to me, fatigue is a real issue. And in the military, especially in the kind of on the shipboard and aviation community, fatigue's almost like a badge of honor. When I would be deployed on Coast Guard cutters, it would be often where members of the ship are bragging that they only had like 4 hours of sleep the night before and had 8 cups of coffee and are still going strong. And I bought into that system for a while until I realized really how dangerous it was and how poorly we're setting up our people for fatigue-based mistakes, which is a very, very real thing. And so when you think of fatigue, there's 3 different types of fatigue. There's transient fatigue, cumulative fatigue, and circadian fatigue. And so transient fatigue is fatigue that's brought up by severe sleep disruptions for like 1 or 2 days. And so for me, that could be getting launched in the middle of the night on a search and rescue case for a couple days. And so by day 3, really exhausted and certainly not operating as best as I possibly can. For maybe commercial pilots, that could be as something as simple as, being at home with a newborn baby where, they're up that night taking care of the baby but still have to meet a flight schedule down the road. Cumulative fatigue could be mild sleep disruptions over the course of a series of days. So instead of getting 8 hours of sleep, you're getting 7 or 6.5. So you're not fully recharging, and that sleep debt is just slowly building, which can have serious consequences. And then circadian fatigue is basically operating in your circadian trough. And what that is, it's typically from 2 a.m. to 6 a.m. where your body is expecting to be resting. And so that's when you should be having your best type of sleep. But if you're operating in that time period, it's throwing your body out of whack. And as a Coast Guard aviator, and especially doing the counter narcotics flying, I was exposed to all three types of fatigue routinely. There's a lot of times I was being launched in over a series of days, 3 or 4 days, at 2 to 3 a.m., which would be, right in my circadian trough, flying for 4 or 5 hours, going after a target during that period. And so we have, some crew rest requirements that tries to help that, but fatigue would become a really big problem. And then when we break it up, fatigue, we can break it up into three different categories. So with cognitive, emotional, and physical fatigue. So cognitive fatigue is, mental exhaustion from prolonged concentration. So for me, that was, focusing, trying to execute the mission as safely and as efficiently as I possibly could. When I was going through my master's program, cognitive fatigue, and I'm sure you students can relate with me right now, was studying and absorbing the material like a fire hose, and trying to learn as much as I possibly could, and focusing on my academics and books, and same thing as I went through flight school, because it was rigorous. I was, studying a ton, trying to become the best junior pilot I possibly could. Emotional fatigue is, that feeling of being worn down or burned out. And I would say in the COVID environment, that's something that's really real. And as I've been doing my safety cultural assessment here in Port Angeles, we're recognizing that emotional fatigue is a problem, that, COVID is wearing on people, being somewhat isolated from peers and friends is having an effect. And, seeing the virus spread throughout the country is creating a type of angst that's impacting our workforce. And then lastly, physical fatigue is just being physically tired from doing a physical task. And so flying a smaller helicopter like I do in a very aggressive way, my body would become taxed. And helicopter crew rest requirements are different than fixed wing in the Coast Guard. So for me, I'm only allowed to fly 6 hours a day without getting, special permission from continuing on, where fixed wing aircraft can fly, I think, from 10 to 12 hours, because it's a little less physically demanding to fly fixed wing as it is to fly helicopters. And I can honestly say there was times when I would be, executing a drug interdiction, where after 2 hours I felt physically exhausted because of the level of flying that I had to do in order to complete the interdiction. And so here's a great image that I adapted from the FAA that just kind of explains the circadian trough. So in this graphic, it talks about the trough being from 1 to 3 a.m. And I would argue it's probably closer from like 1 to 6 a.m. That's really when your body is going to be degraded. And so that, students out there that are, trying to do all-nighters, I can promise you, you're probably not absorbing the material like you should be if you're staying up between, 1 and 6 a.m. because your body just can't process it. That's, the sleep is really, really important. And I've become a much bigger believer in that. And some interesting things you can just see on this graph anecdotally is, right between noon and 3 o'clock, your body starts to become more fatigued, which is perfect. I got the after lunch crowd on the East Coast. And so if you're feeling sleepy, it's not because I'm a terrible speaker, it's because of your body. Your body is telling you that it's time to rest. And so before we get too deep into fatigue mitigation, some things to understand is as you go into that fatigue status, either between cumulative fatigued and transient fatigued, it does have a major impact on your decision making and cognitive abilities, to the point where if you're only averaging 6 to 7 hours of sleep a day for like 2 or 3 days, your body is really performing like you have a blood alcohol level of like 0.1, which in pretty much every single state is legally drunk. So keep that in the back of your mind. If you haven't gotten good sleep over the last couple of days as you're strapping to an aircraft, that you could be considered legally drunk by your cognitive abilities. And so that was really eye-opening to me as I understood that. And as I've passed that to my peers in the Coast Guard, it's been kind of shocking because, we would absolutely never strap into the aircraft after drinking, but it was a norm to strap into the aircraft after just feeling tired. You just chalk it up, yeah, I feel a little tired today in our pre-flight brief. And then everyone says, okay, sounds good. We'll just, watch it and continue on. So as we start thinking about fatigue mitigation, there's a couple things you can do. You can shift sleep patterns. Like if you have to operate at nighttime, you can go reverse cycle where you're sleeping during the day and operating at night. And then, looking at shift work. And so when I was doing the counter narcotic stuff, that's exactly what we do. Is I would, push my day I would go to bed around 4 in the morning and then sleep until about noon. And so that really got the stereotype up for the lazy pilots on the ship, because we'd be sleeping all day and staying up all night. But that's when we were doing all of our flying, was nighttime, because the drug smugglers have recognized it's nice to have the cover of darkness in order to try to evade running drugs. Another very popular fatigue mitigation strategy is caffeine. It's highly utilized, but as I've found, it's really not good for you, especially people that are drinking 5 to 6 cups of coffee every day. I'm certainly a coffee drinker, but it makes me think twice. It makes me really understand what I'm doing to my body. So if you start ingesting, the 5 to 6 cups of coffee every day, or having those energy drinks, you're messing with your body's chemical balance. You'll have a higher likelihood of heart disease and other cardiac related events, even at a younger age. There's a couple studies that I read from people to 25 to about 40 were having more cardiac negative events based on caffeine intake. So just think about it. Think of potential risks that you may have by ingesting caffeine, and weigh that with the gain. For me, I love a nice cup of coffee. I like the taste of it, and so I'm not going to cut it out completely, but I'm just going to recognize that if I'm going for that second, third, fourth, fifth, or sixth cup, that it could have major negative impacts on my body. But the biggest thing is sleep. Get that 8 hours of sleep every day, the best you possibly can. Don't, work yourself to death during the week and then think you can sleep for 16 hours on the weekend on, all day Saturday, and that you're recovered, because you're not. Your body doesn't repay a sleep debt quite like that. You have to just continuously try to get those 8 hours of sleep. And there's a lot of people that I've come across that said, well, hey, I only need 6 hours or 5 hours of sleep to operate effectively. And that may be true, but science has shown like 95 to 97% of the population needs 8 hours of sleep to work effectively. And so as we're all kind of talking about fatigue, this is kind of a nice little segue and shameless plug for what I'm doing for my PhD work. And so some of you may have heard earlier, I'm really into the human-machine interface and monitoring. As a pilot, I'm really good at monitoring the aircraft and knowing what those indications are, and I can quickly diagnose types of emergencies by looking at my warning, caution, and advisory panel and other alerts. But there's no real monitoring process for the human, other than myself. Like, I'm self-monitoring, which can be tough because I have my own bias. I have my own kind of wants and desires for mission success. Like, I'm I'm a type A kind of person. I want to succeed, and I want to ensure that I'm doing the mission the best I possibly can, potentially at my own personal degradation. And so that's something that's really important to me. And so what I want to do is you utilize machine learning to determine a fatigue level in a pilot. And so your voice is a great biomarker. So what I'm hoping to do is to have, a computer analyze a pilot's voice, an aircrew's voice, real time as they're going through a checklist. And so in the Coast Guard, we have checklists for everything from, taking off to leveling off at an altitude to landing to executing a hoist. And so if I can get the computer to understand the words and the way the pilot is speaking, and then have some type of an alert to the pilot on like the WCA panel, say like check fatigue. And now we have a physiological emergency procedure, which would be something that's completely different, because all of my EPs in the H-65 are machine based. So it's problems with the helicopter. But I think it would be really interesting to be able to alert the pilot that, like, hey, you're operating at 60% of where you normally should be. Is the mission worth it? Are you just going out and doing a training flight, or is this a legitimate search and rescue case where you have confirmed people in the water? And for those cases, operating at 60% to save a human life is completely adequate. And I would certainly press on in order to effect a rescue. And that's, part of my job, and that's part of my risk management strategy, where I know there's going to be instances that I have to continue operating at a physically and cognitively degraded state to effect a rescue. And so in that case, I would still want to have the machine, monitoring, my fatigue level and cognitive capability. And then when I reach a certain level, what I'm hoping to do is to provide a type of motivation to have spontaneous recovery of the aviator. And what we're not looking to do shock therapy or, inject, some type of caffeine or pop a pill of caffeine to spur that alertness. I'm hoping to use voice or like music. Think of, if any of you are runners out there, when you're doing like a 5K or 10K or another type of race, how you feel pumped up as you're running, turning that corner and seeing the crowd cheering for you. You feel a sense of fatigue recovery, like your legs don't hurt as much anymore. You're able to pick up the pace for that last 200 meters or so. And that's what I'm hoping to do, is have fatigue recovery for like about 20 minutes so the pilot can safely get to a landing site, even if it's not the home field, but just so they can get the aircraft safely on the ground. And make a decision on, are we done flying? Do we need to go take a nap somewhere at an FBO, or what the next step is? So that's what I'm trying to do with Tufts University, and then also an SNHU alum, Dan Hannon, who's a professor at Tufts, but he got a master's in psychology from SNHU. And then one part that I think is really important, especially now, and like I said earlier, it's solidified it to me as I've done this visit, is emotion. And emotion has significant impacts on decision making, especially stress. So stress will cause some type of cognitive delays. I know I've been stressed out in the aircraft, and I call it vapor lock. Like, I'll just be staring at something, and internally I know what to do, but I'm not effectively communicating that or taking the appropriate action at the necessary time. Like, I'm just kind of like stunned. And so that's important to recognize and to communicate that effectively with your crew. And as we talked about emotional fatigue, that certainly impacts your decision-making skills because you're tired. And the graphic I have on the right is essentially what we use as the Coast Guard decision-making process. So what we're trying to do there is, we gather the information, we look at the different types of information, we evaluate it to see what it is, we start thinking of what we're going to the decision we're going to make and how is that going to be impacted. And then we start to develop more of our course of actions. We again look at consequences. If I continue flying now, is that going to put me in a bad position later? Again, establish those contingency plans, and then finally implement the decision. I know this looks like a really drawn out process, but we, typically do it in seconds. Like, as a professional aviator and professional aviators yourself, you're doing this rapid decision-making process, and you're probably going through all of these steps just very, very quickly. Excuse me. And then, an important part of emotion is recognizing emotional peaks and valleys, where in the Coast Guard and in this type of mission set with search and rescue, you will have really high highs when things go well, and then you'll have very low lows when things don't go well for you. And understanding how that's physically going to impact you. I know for me, when I get stressed and when I'm in one of those emotional valleys, I get tired. Like I feel like I could just sleep all day, and that's one of the things that I recognize, that when I'm super stressed, I'm tired, I want a nap, and for me it's important to recognize it, maybe take a little bit of a nap, but then getting out and doing something active and physical in order to help manage that stress. I like to go run, I like to go hike and bike and things like that, and that helps me recharge and kind of reducing that stress. Another big thing, especially in the military, what we talk about is compartmentalization versus rejecting the mission. And so there's some times where, we'll have personal baggage that is hanging over us that's stressful, like either home life or work life, things like that. Or, you had a really bad mission prior where, potentially it was a search and rescue case where you weren't able to effect the rescue. And unfortunately, there was a fatality or something along those lines. It's hard to, strap into that aircraft with that hanging over your head. And so you have to compartmentalize and just not necessarily suppress that emotion, but understand that it's there but focus on the task at hand. And then there's other times where it's acceptable to reject the mission. There's been times where I haven't been able to go fly because of something else happening, and saying like, hey, like I'm not in a good position to fly. I was up all night doing something. My dog is sick. My wife is sick or something like that. And even in flight school, it was something that the Navy, discussed quite a bit of, if you're not 100% ready to fly, it's not worth it, because the training isn't going to be super beneficial. And when I was an IP doing like standardization checks or instrument checks or different things like that, one of the first things I would tell the pilot I was evaluating and ask them is, where do they think they are? Are they at like 90% or 100%? Because if you're not operating at that high level on a check ride, unfortunately, if things don't go on the check ride and it creates a failure, I can't go back and redo the check ride. If you say, oh yeah, like I was really stressed out because of X, Y, or Z, or because I didn't sleep well the night before. So that's why it's important to acknowledge that those kind of emotions right off the bat. And so now, just going to shift gears a little bit. So we talked a little human factors, and now I'm going to try to apply it to an actual case that I had just over 2 years ago. And so I was deployed on a Coast Guard cutter in the Eastern Pacific, doing a counter-narcotics patrol. And it was Coast Guard Cutter James, which is the ship that you see there. At the time, it was the newest Coast Guard cutter in the fleet. Super capable, great platform to be operating off. And we're working for this thing that's called JIATF South. So it's Joint Interagency Task Force South out of Key West, Florida. And basically, it's a conglomerate of DOD and DHS assets and units, all going after one goal, which is to stem the flow of transnational drugs. And specifically here, we're looking at cocaine and trying to stop that from entering the country at the source, or as close to the source as we possibly can, getting it, interdicting it in the high seas before it has a chance to reach land, because it's really hard to stop. So in this case, the Coast Guard Cutter James had my helicopter, which we were call sign Endgame 19, and then also had 3 small boats at their disposal. We had a Navy Maritime Patrol aircraft, which is a P3, which is kind of like a spotter. So it's an airplane that's flying overhead and just looking for targets in a defined search area. And for us, a target is a go fast boat, which I'll have some imagery here coming up. But before we go too deep, just to give you a little Coast Guard AUF 101, just so you kind of understand what I'm talking about, is this program started in 1998 because we were trying to stem the flow of drugs reaching the U.S. as part of the war on drugs. And historically, helicopters used to just chase boats and tell them to stop sternly, and the boats would wave and continue going. And so we needed to have a type of method in order to physically stop a boat. And so what the Coast Guard did is they armed crews with weapon systems. So we use an M240, which is a machine gun that you saw earlier, to do a series of warning shots. And then now we'll also use an M110 and an M107 sniper rifle. And so in those cases, we're shooting out the engines off of the boats, so outboard engines. We have highly trained pilots in the Coast Guard. You have to be a second tour aviator and go through a couple syllabuses in order to do the job and really understand it. And then we also have qualified snipers, and they're the precision marksman aviation, and they're Coast Guard snipers that are also our flight mechanic, basic air crew qualified people in the back. And then there are snipers that went through, I believe it's the Army Sniper School. And so very highly trained, great marksmen in order to execute this mission. And we have an essential process prior to performing an interdiction. Like, we're not a bunch of yahoos kind of going out there and shooting out engines left and right. We go through a process of asking permission, positively identifying the target, that this is a suspected drug smuggler based on certain criteria. And then even then, we do a series of warning, audio warnings to the boat to ask them to stop. So we'll call them on the radio in English and Spanish, asking them to stop. And then we'll signal them by doing warning shots across the bow. That's highly noticeable, so you can determine that this is a U.S. Coast Guard asset trying to stop a suspected drug smuggler. And then from there, if the vessel still isn't stopping, that's when we'll go into disabling fire and shooting out the engines. But the biggest thing is safety is paramount, and that's safety of everybody involved. So the helicopter, but all the way down to the go fast and the occupants. If I don't feel like we can execute a safe shot or create a shot that would potentially wound one of the people in the go fast, then we just wouldn't take it. It's not worth the risk. We're not out there to hurt people. We're out there to identify who they are and see what kind of material they have on board. And so just to give you an idea, this is where we're operating. So off the coast of Central South America is primarily what's going on. So drugs are usually being run, cocaine specifically, from either Ecuador or Colombia, near the Galapagos, and then trying to get to Central America, either Guatemala, El Salvador, or all the way up to Mexico. And from there, it gets distributed and tried to be pushed through the southern border somehow. And so on this case, particularly, it was a really complex case. Our target was a low-profile vessel, which was carrying about 3,500 kilos of cocaine. So that's a lot of cocaine. I think it's close to like 6 tons or so, 7 tons. And the bottom right picture is what the LPV looks like. So it's designed to not be seen. And so it travels relatively slowly, trying to get through detection as it makes its voyage. And in this case, the LPV was then offloading its load to the go fast, which is that top image. And so go fasts, they're designed for speed. They're also designed to look like fishing vessels. And so that's kind of a normal, fishing panga on that top picture. And you can see those bales, and that's, what a bale of cocaine would look like. Each one is, normally about 80 kilos or so. And so in this case, we had the MPA overhead, and they were monitoring this offload. And it was right around 11 o'clock at night when we first got the indication, and we ended up flying 2 sorties. So between 11 p.m. to about 4:30, 5 in the morning. The weather was, I call it typical drug interdiction weather. It was near zero illumination with scattered thunderstorms throughout the area. And so in these cases, we're wearing night vision goggles and also a heads-up display that attaches to our goggle. And so we were operating just about 30 miles to the north of the cutter. And so this is just kind of a general layout, just so everyone can understand. And so as we got on scene, the go fasts kind of scattered. And so they knew what we were trying to do in trying to affect the interdiction. And so we overflew the LPV, made sure that it was stopped and had marked its position. And then we transitioned to panga number 1, where we did went through our process and got all the way up to disabling fire. From there, we transitioned to panga number 2, and again went through the whole process. In this instance, we had an interesting human-machine interaction between the helicopter and the panga, where they illuminated a white light that blocked our night vision goggle picture a little bit. And so it made it a slightly more tricky interdiction, but we have, I was able to use a searchlight in order to kind of minimize the effects and mitigate the effects of that light. And then here, after we affected that interdiction and stopped that vessel with disabling fire, we went to panga number 3 and went through the same process. And there again, it was really interesting human factors, kind of real-time problems of they did the same thing, illuminated a white light, and then they also understood some of the limitations of our helicopter and went really slow and turned downwind. And so in this case, we elected to, we call it opposing heading disabling fire. And so we flew backwards in order to affect the interdiction. And so it would really only work by knowing the limitations of myself and the limitations of our machine in order to complete that mission successfully. And so after that, we went back to the ship, and we were able to do all this in about 45 minutes or so, or 50 minutes. And so it's a really rapid process, and we felt amazing. We thought we were the best pilots and air crew in the Coast Guard. It was like landing back on the cutter, like Top Gun. Everyone was cheering and super excited. And then we were told we needed to go back out and herd the cats and make sure we have knew the position of all the go fasts, and then get our Coast Guard assets on the go fasts in order to complete the interdictions, make sure everyone was okay and safe, and then get them back on the cutter. So that was the goal. And so we departed for a second flight, and that's when it all went wrong. In this case, we flew into a squall system at about 150 feet over the water that I didn't necessarily recognize. In that case, as we were flying around, I think the first thing I said is like, it got really, like, it's really dark out here. And then my gunner said, yeah, it's really dark, and I think it's raining. And as soon as he said, I think it's raining, the helicopter started buffeting as we flew deeper and deeper into this squall and we went from anywhere from about 150 feet down to 80 to 75 feet and back up. And it was raining so heavily that we heard the rain on the windscreen over the noise of the rotor system and the engines. And so it was really loud. And so from here, on the human factors perspective, it was really interesting because our automation, our flight director modes weren't able to hold the position because of the severity of the weather, because there was so much wind and rain that was affecting our ability to maintain a position. We were flying at about 80 knots indicated, and I started getting an indication confusion because on my heads-up display, I had this hover vector indication that popped up that said, hey, you're in a hover, and this is the direction you're going. And so for me and the other pilot, we thought we were at 80 knots, that we were flying straight ahead at 80 knots, whereas the helicopter thought we were in a hover. And so initially we thought we had a pitot system failure, that, you know, something isn't going on, you know, correctly with our aircraft systems. And so we tried to diagnose that over the course of a few minutes as we're still in this squall line. And talking back and forth, asking the co-pilot what his airspeed indicators are saying in VSI's vertical speed indicator, and determining what's going on. And it wasn't until I continued to look down through my indicators and had a teeny tiny indicator that told me my ground speed and actual winds. And so my ground speed was about 5 knots because I had a 75 knot headwind based upon the weather system. And so that was pretty eye-opening to myself and the pilot. And we recognized we were in a really bad position at that point. And so lastly, there was kind of human to human factors problems with confusion between the ship and the aircraft, that they didn't understand necessarily how bad of a position we were in as we were, you know, trying to fight our way through this squall system, you know, continue on with our mission to make sure we have get the Coast Guard assets safely to the disabled vessels. And every time we tried to communicate effectively to the cutter, they were concerned with all the other assets. And so it created a really confusing situation. And no one other than us really understood how bad the situation had got inside the aircraft and in our area. And so that added about 15 minutes to the mission of really high risk, danger flying because of a breakdown in effective communication. And so this is just kind of like a rudimentary human factors analysis that I had put together on this case. And so, you know, one of the most important things I think in this profession is to be vulnerable and admit to your mistakes and to teach others from it. And so that's what I'm, you know, trying to do here. And so going kind of from the top down approach, looking at the organizational influences, there was, you know, some culture stuff. For me, it was a norm, you know, to go out there. I felt like I needed to go out, especially after how well the first flight went, that I needed to, you know, go out and help protect our boarding team members on their boats, and so they could safely get on the disabled vessels. And then also, you know, we didn't necessarily have a clear policy of, you know, what to follow based on, you know, weather. There is, you know, guidance saying, you know, we needed like a visible horizon, but nothing too much beyond that. So it was important to me to understand that in the future, we may need to tighten up on some of the policy or create other policy so people don't go into those risky situations. The next aspect of it is supervision. You know, it was inadequate supervision. You know, for us, we were relying on someone on the ship to watch our back in these weather systems. And so we have a rudimentary weather radar on the helicopter. And so we didn't see this weather system developing right on top of us, whereas the cutter potentially could have. But it was such a complex case and so many different assets involved that everyone was getting spread really thin. And so we didn't have that top cover that we had normally expected on some less complex case. And then when we get to preconditions, obviously the environment was really difficult to be operating in, with thunderstorms, you know, darkness of near zero lunar illumination because of cloud cover and lack of a moon. The technical environment was interesting because it's, you know, a rather old aircraft that has some old systems, and it doesn't, you know, potentially have, you know, the great weather radar or great or potentially really good indications to let us know that we were going down a bad route. And then, you know, lastly, sensory misinterpretation. Like I interpreted the HUD completely wrong initially. I went down the rabbit hole of thinking it was an indicator problem with my airspeed indicator and thinking it's some sort of pitot system failure, when in reality, it was the environment with a really strong wind. And then lastly, on the human side, things that I certainly could have done better in this case was I had an inadequate real-time risk assessment, where I should have recognized early on that, going on that second flight might not have been great, or as soon as I got the inkling of something bad happening, that my risk had gotten very, very high, whereas the gain of the mission was low to moderate. It wasn't a really high gain mission. We weren't necessarily going out there to save a human life. We were interdicting drugs. And so maybe I could have had a better risk assessment and understood that picture a little better. And then failure to prioritize the mission set. We could have done a better job as an air crew to prioritize our tasks, not go down the rabbit hole of indicator failures, and effectively communicate to the cutter that we're in a really bad position. We need to get back on deck immediately before the situation deteriorates further on. So that's just a really quick human factor snapshot of this case, and particularly what happened. So that's all I have. I appreciate everyone listening to what I have to say. Hopefully you got something from it, and it's a piece of unsolicited advice that's taken me pretty far is, as a pilot, be vulnerable, admit to your mistakes. And that's when a lot of learning happens. For us in the Coast Guard, it happens over, beers in the wardroom, and sitting there and talking and sharing these stories and saying, hey, I really gooned this up, and this is why and how. And now everybody has learned from your mistake. So I appreciate it, and thank you so much.
Thank you so much, Rob. That was fantastic. I think we'll open the floor now for questions for Rob. So does anybody have any questions? You can either unmute yourself, or you can use the Ring Central group chat feature to ask Rob your questions.
Rob, have you ever seen the video by Captain Deli, Sex and the Naval Aviator? It's all about compartmentalization. It's a come-on title, obviously, but I saw that when I was going through a refresher training at Little Rock, and I think he copyrighted the film. I used to have a copy of it that got destroyed, but it was very uncomfortable to watch an hour-and-a-half video on compartmentalization. Although it was oriented towards naval aviators, it really could apply to a lot of other specialists, physicians, lawyers, engineers, you name it.
That's interesting. I'll have to check that out. So I see a question here from Wyatt in the chat on what is the best way to pay back sleep debt, and then is there an alternative to caffeine or coffee? For me, the best way to pay back sleep debt is to really just get that 8 hours and not go into a sleep debt if you possibly can. And so just to get as close to those 8 hours as possible, and have a nice sleep environment. For an alternative to caffeine or coffee, again, just try to effectively get that sleep of 8 hours, and drink a lot of water. Water is a great substitute, keeps you obviously well hydrated, and it allows your body to be operating at its peak performance.
That's great, Wyatt. I think that's the classic college student question, right? How can I keep my performance up on minimum sleep? What other questions?
There was actually a position paper that I've read before. It's put out by the Aerospace Medical Association. It was from 2009, and it kind of goes over, it's called Fatigue Countermeasures in Aviation. And it's a very extensive paper. It talks about things that you can do, like, different ways of handling it, including the use of medications. But it's a long paper, but it's kind of the summary of all the known ways to deal with fatigue in aviation. It's a little old now. It's 11 years old. It's still out there.
All right, there's a couple other questions. How do you manage an adrenaline high if you must sleep soon after? That's a great question. I've certainly had a lot of those adrenaline highs doing this mission. And so for me, what worked is one, just recognizing that I had an adrenaline high and that I needed to come down off of it. And so what we would do as a crew is we'd go back, we'd call it the mess deck, which is kind of a common area on the ship where we would all eat. And we'd play just like a game of cards and just, talk for a little bit, as opposed to, going our separate ways and trying to go to sleep. We'd recognize hey, it's going to take us a little bit. And so now we're not just sitting in our beds, staring up at the ceiling awake. We would play a round of cards or two, start feeling tired, drinking water, and then heading off to bed. And so we weren't trying to force the issue, which could make it a little worse. And then recognizing, we're going to try to have, that 8 hours of uninterrupted rest. And then the next question I see, what kind of personal mental checklist do you go through before your flights? For me, I'm not sure if everyone's familiar with it, but I go through the I'm safe checklist. So illness, medication, alcohol, sleep, fatigue, and eating. And so to me, that's really important. Just going through that, cognizant checklist, and I'll ask the people I'm flying with, the other pilot, my flight mechanic, my rescue swimmers, will say, are you safe? And everyone will kind of go through and run it through. And as a pilot, I'll also ask, hey, how many hours of sleep have you had in the last, day or two? And if someone says oh yeah, I've averaged 4 or 5 hours the last couple of nights, I'll ask okay, well, how are you really feeling? And it starts the discussion. And to me, that's the most important part. We'll have crew briefs, and what I'm really trying to do is get a discussion of what's going on to get everyone on the same page, CRM wise, before we enter the aircraft, so I can understand how everyone's going to perform. So I'm not surprised, as we're trying to do a really complex hoist, and the mechanic is making mistakes because they were tired, or if I'm the safety pilot, I'm not monitoring as well as I could because I'm tired and I'm getting distracted. And so that's, really important in these high risk mission sets.
And there was actually some other questions on here as well, Rob. Rich McKenzie asked, do you know if the Coast Guard has any future plans to allow for reserve aviation opportunities?
That's a great question. I'm probably not the person to talk about that one, but I do know people have asked it, and I don't foresee it here, at least in the near future. But I know there's a lot of people that are pushing for having some Coast Guard air reserves.
There's another one attached to that too. So do you see a shift taking place in the culture of, I didn't get enough sleep last night, as a badge of honor on the military or civilian side?
Yeah, and I also I think there's some cultural differences as well. As an aviator in the Coast Guard, we have a very different safety culture as the cutter community, and not to bag on the cutter community, too much. They don't take the same type of safety stance as we do, and it's no fault on them. It's a different mindset, and so still I think that's going to be a hard transition because of staffing, and then also mission requirements, that there are instances where a cutterman needs to be up for a prolonged period of time, and it could have really negative impacts. Looking at, I think the most recent example of a maritime accident based on fatigue was a couple Navy ships. A Navy ship ran into a tanker, and it turned out that their OODs and members on the bridge had been up for a long time, and were heavily fatigued based on what they had to do. And so I would hope that we can start to have a type of cultural shift, but it will take some time.
Thanks, Rob. And were there any other questions for Rob? I think I heard someone on mute a second ago.
Yeah, I have a question, if you don't mind. Hi, Rob. My name is Dale. I'm an adjunct here at SNHU, and am a pilot in the airline world. On the civilian side, we've got risk analysis tools as part of SMS programs and things like that. When you are the team to respond to a mission, how do you evaluate risk before taking a flight that you are the only person there to conduct? How do you say no?
Yeah, that's a great question. And saying no is very, very hard. Especially when a human life is on the line. And so my personal philosophy is, how can I get to yes, to save a human life? And so I'll do everything possible. So some of the tools I use is the PEACE model for kind of risk and hazard identification. And so PEACE is planning, environment, aircraft, communication, and event complexity. And so we'll start going through the plan. What's going on? What's wrong? What's the weather for the environment? Asset. How's our personal asset? Like our bodies, and how's our aircraft? Is it a degraded aircraft? Does it has everything on it operating that we need to effectively complete the mission? And then also another big part is, what other assets are available? Can this be completed by a small boat? Is there a Coast Guard cutter around? Is there a fire or a fire department boat around that can go out and help? If it's a vertical surface, can I get a fire team down there to rappel to the person? And then communication is, who are we going to talk to? How are we going to talk to them? And then lastly, event complexity is obviously, what's this mission set calling for? How hard of a mission it is. Do I need to bring in a different pilot or a more experienced mechanic and rescue swimmer to effect the hoist? And then we look at STAR, which is really kind of, so PEACE is like a deliberate risk assessment when you're talking about SMS, where STAR is like the real time. So it's spread out, transfer, avoid, accept, or reduce the risk. And so there's been plenty of times where I've just had to accept the risk and be like, this is a high risk mission. We're going out to save a human life. So this is as high of a gain as it possibly gets. And so I have the authority to potentially break the aircraft and cause aircraft damage in order to effect that rescue, to save a human life. And so it's kind of going through that process, how can I spread out the risk? Can I have another asset on scene to help us out? So those are our normal processes.
Great, thank you.
Yep.
It's always, Dale, great question. A couple extra ones were added here on the chat section. Charmaine asked, how often do you reevaluate your personal minimums?
That's a great question, and it's constant. We're constantly reevaluating ourselves, especially on these high flights. Like, I'll ask the question to the crew, like, how are you all feeling? If we're going out there flying at that 3 a.m. and I hear people not talking and not being as chatty as they typically are, that's my number one indicator that people are getting tired and that there's something going on. And so how can I get people to be alert and re-engaged into the mission? Or does that mean, we need to go back? But I would say it's constant of reevaluating ourselves and reevaluating the mission, going through those models of PEACE and STAR.
That's great. And I think another one was just added here. Rob, do you have it?
Yeah, it says, has there been a shift away from the ORM framework that included in-depth, deliberate, and time-critical? I wouldn't say there's necessarily a shift away. We've just found that doing the deliberate and real time kind of encompasses it all. And we're also moving, more from, the tenets of CRM, DAM class, if you're all familiar with that, like the decision-making, assertiveness, situational awareness, and so on, to go into more of the threat and error management type of model. But we're very much, we enjoy doing the deliberate and kind of real time, which would be like that time critical part of ORM.
And does anyone else have questions for Rob? waiting, I'll just mention again, if you are looking for FAA WINCS credit or MBAA CAM credit, just send us an email at snu.edu with the events that you attended, and we'll get that taken care of. In case anybody logged in late and didn't get to hear us spiel it early on. Well, great. I think that's all the questions that we had. Rob, thank you again for doing this. It was an absolute pleasure, and I definitely learned a lot. So, thank you for challenging us on our understanding of human factors, and due to Tufts and the location of Tufts close to SNHU, when the pandemic winds down, we will have to have you up here in person to talk to our students in person. We got to make that happen.
Yeah, absolutely. Thanks again for the opportunity, and I really appreciate it. If anyone has any future questions, I'm on LinkedIn. I don't really do the social media thing so much other than that. So that's probably the best way to get a hold of me. But yeah, thanks again. I hope I didn't babble too much and made some sense. So thank you.
That's perfect. Thank you so much, Rob.
Great. Thank you, Rob. Great picture too, by the way, at the end of your presentation.
Yeah, thanks. Yeah, showing off all the Coast Guard assets there.
Great. Thank you for your time.
Yep, absolutely. Thank you.
Thank you, sir.
Thank you.
Here, and I'll just drop in my email into the chat as well if people want to ask follow-on questions. So there it is.
Perfect. I forgot to mention too, for those that are still on, we will be meeting with Dave Cardulo from the Boston FSDO on the maintenance side of things at 2:30. So we hope to see you there too.
Hey, Dom, if you don't mind, can you hang on the presentation for 2 seconds? Rob,
Absolutely.
just a follow-up question to that. Are those models standardized in your safety program, or is that just something that you personally like to practice?
No, that's standard. And so if you Google Coast Guard Risk Management Manual, you can find it right there. And so we also use called GAR 2.0, and GAR 2.0 incorporates peace right into like the planning. And
Excellent.
so my personal goal for this job that I'm in now is we do a pre-flight crew brief where we go through the entire mission set. And it kind of mirrors the peace model already. And then we'll do an ORM brief at the end of it that is purely peace model. Cool. But to me, people get like briefing fatigue, and everyone starts tuning out after like 5 minutes. And
Sure.
so I want to make it where the pre-flight brief is just peace, because we're going to hit all the same wickets as it is.
Excellent. Very cool. Thank you.
Yeah, absolutely.
Yeah, once again, thank you very much, Rob. This was amazing. And yeah, really look forward to seeing you in person.
Yeah, absolutely. Let me know.
Campus.
Yeah, let me know if there's anything I can do to help out in the future. So I love doing this kind of stuff and talking about it. So it's great.
Well, enjoy your West Coast time.
Yeah, thanks.
You got a busy day ahead of you still.
Yeah, we're gonna go do an out brief and figure out how we're gonna get home.
Thanks again, Rob. And I might send you an email. I just started my doctorate as well, and would love to collaborate a little bit on what you're researching. It's very
okay. Yeah, that'd be great. I look forward to it.
Great. Thanks again.
Yeah, thanks again. So all right, well, I'm gonna sign off. I hope you all enjoy the rest of your day, and thanks again.
Thanks, Rob. See you soon.